right. Sorry, I am late. Did not want to go live. So it's my first time doing this kind of thing. I have no idea what I'm doing. And we're just going to go for it and see how it goes. So it looks like we got 3 people here. 4. So I'm going to just wait a minute or two just to see if we get any more people in here. Does anyone have a question that no one cares about at all? We could do that to pass the time while we're waiting for folks to come in. If no one has a question that no one cares about, see if I can come up with one. Hello, the old mad. How's it going? Also, thanks everyone who thought it was worthwhile to tune in and watch me talk. This is definitely not the how's the weather? That's exactly what I was gonna ask. Let's see.
How about that weather?
I had that ready to go. It's freaking hot, and it's hot down here. I don't know if it's just me, but I'm gonna take this off. So, saying 2 people, that's kind of, was it really that boring? We didn't even get to start. Well, I guess we'll just see how it goes. Thanks everyone for tuning in. I'm glad you guys think it's interesting enough. I definitely appreciate the patronage. Basically all that money is going into making more projects and also improving my AV setup. So all the money I've made so far has gone into getting a better camera. So my other camera, it went to about 1/3 of a new camera. My other camera was so terrible and it always made me look orange, and I spent half my production time trying to color correct. So this is what I've been putting it towards, and I appreciate it a lot. Hopefully it makes for a more enjoyable viewing experience and lets me get more angles. So yeah, we got Australia. I hope, how is this time? That was a thing. I really had no idea what time was good. I just kind of looked at the time zones and tried to choose the middle. Is this a good time, bad time? I know Australia, it probably sucks because it's like, what, 4 a.m. or something? But I think there's a lag. But France, 10 p.m., 22H. Yeah, it seems like there's a lot of people from Europe. So I was trying to figure out like how early I could go without making the West Coast people watch me over breakfast. So, okay, well, if maybe I'll have a poll on times or something. But yeah, let's, I guess, dive into some questions that people had. So there were some questions that were in the chat, and so I have those written down, and I'll try to go through all of those. But if you guys have questions that come up when you're just seeing me talk, if there's something you want to know about, then just ask away in the chat. And then also, you know, this type of thing, it feels like AMA. It's like, ask me anything about me. But projects, brainstorming, you know, hopefully it's not just about like me as a person. Hopefully it's technical too. And anything is fair game pretty much. Unless you know in your heart that it's not, then don't ask. So yeah, let's start with a simple one. Scrolling through. Here we go. The question is, will I be taking live questions or answering based on written questions in the forum? I already answered that one. Write your questions in, and I'll be going through those. Okay, that was an easy layup just to kick things off. The first question I got in the channel, it looks like, is what is my learning process? What do I ask myself when I'm trying to learn how to solve a difficult problem? How do I know what questions to ask? And how do I get exposed to new knowledge that I didn't know about? So it's a really good question, because there's this thing of, how do you know what you don't know? And it's a related question to what's my favorite part of machinery? We'll table that one for a second. It's a good question though, and a hard one. So the idea of knowing what you don't know is it's like a chicken and egg problem. And so for me, when I'm going to something new, usually what I'm trying to do is find something that will give me the keywords, because usually the hard part is just knowing what to search for, what to Google for, what to look in a textbook. And so if it's something totally new that I've never worked with before, say for example, I wanted to, I don't know, study like fossils or something, which I don't know anything about other than seeing Jurassic Park, I would be trying to buy the textbook. I would go and go to Reddit or something. What's the best textbook on this thing? I will buy it. I have a bookshelf full of textbooks from all the things that I've read. I don't always read the whole textbook. In fact, more often than not, I don't. But I will at least skim. And if it's something that I think I really want to know about, I will read the textbook and work the examples. So years and years ago when I was in college, I saw a job for a web development position. And I was a mechanical engineering student, and I had written some iOS apps on the side and some C++ stuff, but I didn't know anything about web development. But I wanted this job because it paid like $11 an hour or something terrible for a web developer. And so I bought a book on HTML, JavaScript, and CSS. I read them. I did the examples, passed the interview, and that built a really strong foundation because I knew how the languages worked. I knew why things worked the way they did. And then I could learn all this other piles and piles of garbage that you have to learn to write web apps, which all that knowledge is probably obsolete now. I haven't done it in a while. But that's kind of how I go about it. The other thing I'll do is I'll look for someone who solved a similar problem and hopefully find just some kind of blog post, anything that just gives me the words. There was a guy I work with that was upgrading his electrical service. He just got a plasma cutter. He's a smart guy. And he was gonna have to put in a new panel because he didn't have enough openings in his breaker box. And he like found the words online. There's a special kind of breaker that fits in one slot. That's a two-phase 240. And if he didn't know the words, he would have installed an entirely new panel like a chump because he just didn't know the right word. Once he saw it, big problem solved. So that's sort of my approach. All right, got a softball for me. My favorite piece of machinery in the shop. So if you say machinery, that actually makes it a lot easier because I don't have that much machinery. I've got the Tormach, I've got the knee mill, which is next to it, the small CNC router, and then maybe the big bender counts as machinery, and plasma cutter. I think if you put a gun to my head and said you get one tool, it would probably be the plasma cutter, because most things that I want to make, I can convert them to bent sheet metal with just a few welds and bends and other things. And it is just so convenient, so fast, so good. It's definitely my favorite. All right. Find relevant textbook. Yeah, that's my first impulse from Taylor. Yeah, that's actually, so the main thing you get out of university is the keywords. So probably outside of this AMA, the number one thing that people ask me is, what do I need to go to college to learn to do what you did, et cetera, et cetera. And honestly, most of what I know, I did not learn at university. The one really practical thing I got at university is that there was a phenomenal machine shop with really good machinists, and I spent a lot of time with them. So that's actually where I learned to do a lot of my machining, and it was all manual. So they were actually journeyman machinists from Lawrence Livermore Labs, the National Ignition Facility, I think they call it, or it's where they're shooting like 50 lasers at a little piece of tritium to try to make fusion. They were the machinists who worked there doing ultra precision optical machining and other stuff with jig borers and really cool tools. So they were very good and very helpful. So that's actually where I learned, and that was something that would be hard to learn outside of school, because I normally say just jump into it and do it, but it's kind of hard to just dive in and buy a mill and then just learn. You don't even know what mill you need. So that was really useful. All right, the example of learning process for one of my projects on YouTube. Let's see. Okay, so when I had some props here. So when I made the golf club, actually, let me get the actual golf club. Okay, so when I made this thing, I bought a very expensive IMU for it. It was like a $300, $350 IMU. It's an inertial measurement unit. And it was what I was using to figure out the pose of the golf club in space. The reason I bought such an expensive one is that it came calibrated from the factory with all three axes orthogonal to each other, and it would actually give you the pose of the club as like a matrix, which made my life a lot easier from the software side, because I would say, what's the pose? And it would give it to me and a bunch of other really useful stuff. But I ripped the communication header off of the IMU, and that was for I2C, which I know how to do. And there was only a USB header left, which I've worked with USB before. I've interfaced with drivers that other people have written, but I've never tried to make my own driver. And so is this decision of like, do I buy another IMU, try to use a crappy one, or just make a USB driver? And I figured the right thing to do would be just buy another one. And at the end of it, I wished that I had, but it also seemed like a useful opportunity to just have to learn how to at least very roughly make a USB driver. And so what I did is I searched GitHub for a really long time until I found an example of a USB driver on the microcontroller that I was using, a Teensy. And then I also downloaded the USB specification, which I had never read before, but it's surprisingly readable, at least the parts that I read. And so the USB specification was critical. If I just tried to look at the code, you just can't even figure out what it's doing, because it's like a 6-layered thing with all this jargon, like a USB transfer and claiming a device and claiming an interface. It's like, what does any of that mean? And if you just try to bang your way through it, I just don't even think I could have. But reading the USB spec taught me what all those things meant, at least roughly. And then the code showed me that in practice. And then I actually took a chunk of that and then adapted it to my application. And then the data sheet for the thing also had, as sort of seems to be typical for data sheets, really crappy documentation, but that helped me a little bit. But it was kind of fusing those things together and just thinking about it really hard for a long time and being stressed out by it. Eventually, I got a thing that worked. What university? I went to University of North Carolina at Charlotte. It is, it's just one of the state-run schools. It's in the, if you may have heard of UNCC or UNC from basketball. If you follow college basketball, it's a sister school to that. And I went there for mechanical engineering initially. And then I was also getting an electrical engineering degree at the same time. And I stopped after 3 years because I didn't feel like I was learning anything. And then I switched and got the prerequisites for computer science. And then I got a master's in computer science because I felt like that was really useful for making stuff. And I'm very happy with that decision. How do I balance my paid work and personal projects? That's a good question. So we're actually back in the office now. We've been back in the office for quite a while because I run a small R&D office for the company I work for in the city. And so we have few enough people here, it's like 15, that in enough space that we can be socially distant within all the guidelines. And so I've been going in, and that makes it really easy to balance the two things, because when I'm at work, I work. When I'm at home, I'm not working, and I can work on projects. In both cases, at work and in personal projects, you always wish you had more time. Like, I wish I could sleep 3 hours a night or something. I can't. One of the questions people ask me is, how many hours a night do you sleep? And the answer is 8+. I find that my mind does not work if I don't get that much sleep. It's really quite annoying, but it's the way that it is. And so the main way that I, aside from being forced to do different things at different times, I really try to focus on spending that time wisely. So if I can, like the IMU example, if I can buy an IMU that I think is going to save me a bunch of work, because I was expecting if I didn't buy the IMU, I'd have to calibrate it and write more code and debug it, and it wouldn't work quite right. I'll do that. That way I can focus my time on stuff that I want to be doing. Digitizing a bus. Okay, so the question is, I'm converting a bus and need to digitize it and exchange files. What's the best software for this? It depends a lot on, so I've never digitized a large scale structure before. So there's actually a YouTube channel. There's a man in Utah who's very wealthy. He's a self-made wealthy guy. His name is, it's escaping me, but he builds airplanes, and he has a hangar where he builds the airplanes. You guys would probably all love this channel. And the thing he's really well known for is a Bush plane with a jet. It's like a turboprop engine in it, I think. And it's called the Beast. He crashed it, but his name is Mike Pate. That's what it is. And he completely redid a plane so he took a plane, a Wilga, I think it was. He rebuilt the wings, rebuilt parts of the fuselage, the landing gear, put a new engine on it, and he had to digitize the plane, which is a very similar problem to what you have. And it seemed like there was a service where these guys came out with a 3D LiDAR or something scanner, and they scanned the whole plane, imported it into some proprietary software, which he talks about on his channel. And then he used that in SolidWorks, I think, to then trace the airfoil and fit everything together. But the hard part, whenever I've tried to digitize something, is actually just getting the data. It's not really the CAD. Fusion 360, once you have all the measurements, it's basically, in my experience, the same as SolidWorks and Inventor. It's a little bit harder to use, but they're all very similar. It's just getting the data. And that, my best recommendation is check out Mike Pate. I think that's his name. And he has a video about that. Yeah, so the energy to work on personal projects, that's definitely something I'm up and down on. I generally just try to find something that I'm really excited about, and that allows me to power through when I'm tired, because once I get going, then I'm good. But if I come home and it's like been a really hard day with lots of fires that I'm firefighting, it's like, I just want to watch YouTube videos or something. But I always really try to think about what will I think of 5 years from now with almost any decision. So if I put a little bit of time in right now to learn a new thing or build a thing, it's going to integrate over time, and future me will be very happy. And if I don't use my time well, future me is going to be like, come on, why'd you screw me? And so I kind of use that as a motivator to, just like when I'm looking at what I do with my money, what I do with my time, or anything, is just what will future me think? And then it's I do it for him. I do it for me a few years from now. And that works for me. Different people, I know there's a million blog posts about motivation and working hard, but just got to find what works for you. All right. See, there's some more questions that were in the Discord. Let's see if I can find one. Have I done any successful projects on the first try without screwing up? I don't really know what that's hard to answer. I've certainly built small things that worked on the first try. Things that are more complicated, like say the backboard that puts the balls into the hoop. It did work. Like, I didn't have to rebuild it, but I did have to reprint some parts because they didn't fit, and the whole process is so iterative for me that there's not a line. I don't usually build a thing and my first idea is what I have at the end, and then it works or it doesn't. It just, the whole process is getting to a thing that works. And so I actually grabbed this robot hair cutter. This is all of the parts that I printed before the final one that didn't work. So this is the vacuum adapter and the threads. So there's threads for the vacuum tube that go into it. They're supposed to be left-handed for some reason, and I printed them backwards. So that screwed that one up. The little fingers that grab my hair took probably 5 iterations before they worked and didn't grab the hair too hard, but would also grab it. Don't remember why I had to redo the whole body. Oh, the pivot for one of the axes just didn't work right. It would slip, so I had to redesign. The scissors were too far back. So that's kind of how it goes for a lot of this. This is why I'm such a fan of 3D printing, is that I can get it, I can try the fit and finish, and then if it doesn't work, I didn't just spend a ton of time making these parts. And so it actually allows me to go faster. If I was machining these, I would be really agonizing over whether it works because of the time sink. It's actually the case for the bat that I'm working on right now. It's almost all machine parts because they need to withstand the blast of 322 cartridges at the same time. So I've been spending a lot more time trying to make sure that it's right before I go machine them. So my first projects that got me started on this path. So I've been making things as long as I basically can remember. And I don't even know what the first thing I did was. My mom told me a story a month or two ago that apparently when I was 4 or 5, her car broke down, or it didn't break down, she got a flat. And she called one of the family friends over, one of my dad's friends, and he didn't know how to change a tire, but I walked him through how to do it. And somehow I don't know how I knew, but I was basically always just very interested in mechanical stuff. As soon as I could use my hands, my dad was giving me tools. He was buying me electronics kits to learn soldering. So like the kits with through holes that you would solder together, and it would be like a siren or something like that. And I was just always in the garage making stuff. I read a lot of, in elementary school, there were a lot of these books on projects, how to make things, where you would usually cardboard, electrical tape, simple motors, stuff like that. I would do a lot of those. There were a lot of these, I don't know if they still make these, but they'd have these 120-in-1 electronics kits where they come with lots of jumper wires and components, and you connect them all with little spring terminal things. And you can make a ton of different projects, like a little radio, like an AM radio, and sirens and buzzers. So I did a lot of that stuff. But I was just really drawn to it, and is what I loved doing. It was actually challenging because I didn't have many tools, and it's probably good because I would have very likely killed myself if I had access to a CNC or a table saw, heaven forbid. So it's probably good for me, but pretty much all I had tool wise was like soldering stuff, a drill, a jigsaw, and then hand tools until I was in college. And so it really forced me to find creative solutions to do things, because I didn't have the ability to make whatever I wanted. And I think that was actually really good, is having those constraints. Once I went into college, I got access to machining tools, and that's when I really started to get skill and stuff, other manufacturing techniques. And the first thing I made there was an air engine. That's what they made us make, a little pneumatic air engine. Some memorable early projects. So when I was in high school, I really got into casting, and I think I have some blog posts on this on my blog, but I really wanted to do spin casting. And like I said, I didn't really have any tools, but I built a spin caster out of a bike. So you would attach the mold that you would pour molten metal into and then crank the bike and the wheel would spin and the centrifugal force would force the metal into the mold so you don't have air bubbles. And I was actually doing it to woo my girlfriend, who is now my wife. And it was memorable because it was so insanely dangerous. I was like behind a piece of plywood cranking this thing, and I had a couple molds explode and just they're red hot because I had to preheat the mold and then fill it with molten metal, and that was pretty fun. And she liked the stuff I made, so win-win. Okay, five favorite essential tools. It really depends on what you're doing. So I can only answer that for what are essential to me. So the way I always think about these things when someone poses a question like this is, okay, you put a gun to my head and you say you get 5 tools, which 5 do you choose? That's kind of how I think about it. And the first, so when I got this shop, the first tool that I bought was actually a compound miter saw. And I would probably put that in the list because you can, so many things you can make out of 2x4s and small pieces of plywood and things like that, like benches and structures and all kinds of things. I think that's a great tool. If you do not have good cordless drill and driver, you are really missing out. This is probably the most used tool of anything. So handy for assembly, punching holes and stuff, obviously. I think in today's modern age, if you don't have a 3D printer of some kind, you are probably spending a lot more time trying to make things than you could. So I use SLA a lot, which is stereolithography. It's a resin-based printing, and that's because I have access to those machines through work. But even a cheap FDM, I also have a Ender, which is like a $200 FDM machine that you can get on Amazon, and that thing's great. So like that fume collector for my welder, the nozzle on the end of it, or the funnel on the end, that's printed on the Ender. It's good and really cheap to run. Okay, so that was 3. So I have this is one that I've seen some people have these, but everyone that I've ever shown this to, they laugh at me and say it's stupid, but I think this is like one of the best tools ever. Let me grab it. This is a desktop bandsaw, and I have a couple bandsaws, but almost every piece of metal I ever cut is on this. The other bandsaws are a pain to set up and they're bigger. So this is a Harbor Freight $99 bandsaw with just a little base that I made. It's just a piece of plywood, and then I have a little panel with a switch for to turn it on and off. But these things are so useful. I bought one for my office where I work, and they're like, oh, what is this toy? But now everyone loves it. And then also at the headquarters, we got one there. Same reaction. Oh, what is this toy? They love it. This thing is fantastic. If you're working with if you're cutting bolts or metal stock or anything, this is great. In fact, the CNC, the small CNC, I did almost all that on this. It's great. And then I get one more. I don't know. It depends on what you're doing. You know, there's so many tools, so many random hand tools that you need. I guess if I get one more, it would be the vise. So I have a huge vise. It's an 8-inch. I think it's huge. Maybe some people are like, that's a small vise, but it's an 8-inch Wilton, and vices are so handy. You can use them for bending. So I have this. A lot of people know these. They're a vise brake. And so you can put sheet metal into the vise and bend it. If you need to break a bolt loose, if you need to crush something, if you need to press something into a hole, they're just really great. I use the Vice all the time. I think if you were just going to buy even a cheap Harbor Freight $30 Vice, you'll use it probably more than you would think. Oh, I'm going to give one more plug. This is the bonus. This is the Baker's Half Dozen. So 6th tool, if you've never seen a jaw horse, so this is a sawhorse that has a giant vise in it. And this jaw is reversible, so you can clamp something that's up to 4 feet deep on it. And I use this really frequently. And so if I'm laying up wood or something, I can use it as a giant kind of woodworking clamp. But it can hold a door. If you have a bigger tool that you want to work outside on, you can put it on a piece of plywood and clamp it in here. And also when I spray paint stuff, I have another one that I have up in my garage that's a beater for painting and other stuff. They're only like $80 or something. And it's a super powerful vise, portable, folds up, fantastic. I bought 2. I would definitely buy one if I was starting again. All right. So was it just the interest that drove me? Yeah, basically. I just get a lot of joy out of it. It's very fun. It's very satisfying. The reason I got into making YouTube videos is that I'm spending so much of my time making these things, and it just feels like kind of a waste to not do something with it. And the way I've described it before is it's sort of like a tree falling in the woods. Like, okay, I made a neat thing for myself by myself, and I enjoyed doing it, but it's not helping humankind in any way. It's just like, does it matter? And so I started making YouTube videos to hopefully share some of the things and contribute back, because I've learned so much from the internet and people also posting videos about things. And then also hopefully entertain. I like entertaining. I think it's fun. I like to make jokes. And so it's also an opportunity to make jokes. So that's what got me into YouTube. But I definitely am much more interested in just making the things. And that's what drives me to learn. And it's a good reason to learn. Some people can just read a textbook for fun, but I don't. Like I buy the textbooks, but I can only read them if there's a goal beyond it that I'm trying to get to. And if I have a goal, I can sit down and read a textbook for 12 hours. If I don't have a goal, I can't. I get bored out of my mind. Yeah, okay, my 3D printing setup. So basically, almost every part that I've ever shown on my channel has been printed on a Form 3. Grab it. So this is an SLA printer made by a company called Formlabs. This is where I work. I was actually responsible for the development of this product. I was I guess you'd call me the program manager. We don't really have titles, but it's a laser-based 3D printer, and it has a tank that's filled with material, and then it cures from below with a laser. And then the parts, I don't have a platform in it, but it lifts the parts out of the resin on a platform that's attached to this axis right here. And there's really not much to it. There's a huge number of materials that they accept, which is really handy. So you can see right here that this is the kind of business end of the haircutting robot, and the parts look a little bit different. And that's because these are printed in a material called durable, which is a super high impact strength material. This is just a general purpose clear material, which prints very quickly. And then it also has really good wear resistance, so it's great for these cams. And so I have all these different materials. This is tough. This is a higher modulus, so it's stiffer than durable, but less tough and a bit less wear resistance, but it's another good engineering material. And then this is Gray Pro. So it's one machine basically. And then I also can print at work. So if I need to print a bunch of parts, I might kick off some jobs there as well. But basically you can just pop in whatever material you need for the application, print, and then you get all your parts. And it's very handy. And I'll usually pack the whole haircutting robot was 2 prints, I think. I ended up doing a few different materials, but all the parts fit into 2 prints. Maybe even could have done it in 1 if I tried. I wasn't trying because there are different materials I wanted. And I highly recommend SLA. So, you know, if I can only have one 3D printing technology, it would be SLA. And the reason for that is it has the best detail by far. So a lot of these parts that I get out of here, they're ready to go. So this is a failed enclosure for the golf club. It didn't fit for some reason. I don't remember what. I think I couldn't get the screen into it, but all the holes are the right size. I have almost every part I make has captive nuts. You'll see that a lot in my prints because it's really handy. The nuts fit. All the holes are the right size pretty much. The only exception is when you have pretty small holes, you might need to ream them. And then it has such a wide range of materials. So being able to print flexible and elastic, castable, these durable materials, it's just can make whatever you want pretty much. And then the third thing that's pretty nice is the materials are anisotropic. So a problem with FDM machines is that the parts tend to break across layers. And so when you're printing something, say I was printing this adapter for the haircutting robot, I would have to be very careful if my layers were going this way because it might split right here. And you just don't have that problem with SLA. They're essentially the same strength in all directions. So pretty nice for that reason as well. And then the only other elements of the 3D printing setup is washing. So these parts, they come out sticky because they're in a tank of resin. So there's a thin film of resin on them. So there's a device that we actually make called a wash. It's a very, very clever name. It just dunks your part in isopropyl alcohol for a fixed time, and then it lifts it back out. And then there's also a device which I use for the engineering materials you needed. I don't typically use it for clear, called a cure. And it exposes the part to additional ultraviolet radiation, UV LEDs, and heat. And then it converts more of the resin. There's still uncured material in the parts. They're totally dry, totally solid, but you can basically create more chemical bonds in the structure, and that's what that does. It makes the part stronger. Oh, yes. So I'm using when I say durable, someone's asking, where do I buy the durable material? So you noticed I said we have a device called the wash in the cure, and we have materials called durable. So a very, very original naming scheme where we just choose a word that describes it, but is a very common word. And so if you want to see the durable material, you search Formlabs durable. And there's actually data sheets on everything. You can see the stress strain curves. You can see the impact strength. And all of those things. There's really nice like spider charts, I think you call them, of all the different properties, and you can see how good they are. They're a lot better than most people think. That's my experience. They're even better than I thought, and I worked there. I couldn't believe how durable did with the golf club. I thought for sure I would just destroy it immediately, and I didn't. And they're really, really quite good. How do I manage my finances and prioritize what I'm willing to spend on tools, machines, etc.? So that is a good question. The way that I kind of approach it is for almost any tool that I buy, I have a list of like hundreds of tools that I want. And I generally don't buy them until I really need it for a project. And then I will put off projects that are expensive. So there's until it's like the right time and I have money and it's the thing I want most. And I kind of base it all on, do I need this? Is this worth it? And what am I not able to do because of this? So you can see that I don't actually have a big lathe. I've had a large lathe in my list of things I've wanted for years. I just haven't needed one. And when I look at the price of them, I see all these other tools that I would want more than it. Therefore, I don't get the lathe. And there's a couple of projects that I would want to do that need it, but it's not worth doing that project because I have to buy the lathe, which means I don't get to buy those other things. And so it's all about opportunity cost. And that's not maybe like a formula for how I do it, but it's kind of how I just think about it. What is this at the expense of? And that's the rough formula. What the project that I've been putting off that's very expensive, if you're interested, is, so I'm very interested in flying and airplanes and things like that. And I've had making a 6 Degree of Freedom simulator in my list for a really long time. I actually did a good bit of design on it, but when I was looking at the motors required to do this, they're so expensive. It's like $6,000 worth of motors. So that's not going to happen. Maybe if I can find someone to give me the motors, that's one of the nice things about YouTube, is maybe I could get someone to sponsor me and give me the motors. Then maybe I would do it, but it's just not worth it otherwise. How did I learn to draw? So part of making things, especially pre-free Fusion 360 and CAD and all that stuff, was learning to draw your ideas and figure out how to do them on paper. So that's actually where a lot of my technical illustration and stuff just came from trying to figure out how to make things when I was a kid. When I was in high school, I got a drafting certification. I went to a school that had a vocational program, and I did like 3 years of drafting class, which got me a draft cert. We actually started hand drafting with pens the old school way, then 2D and then 3D. That's also where I learned a lot of my CAD skills. I actually competed. I never would have known this if I didn't do it, but there's actually CAD competitions that are regional and national. And so I was Mr. North Carolina, the draftsman or whatever. I won that, and I competed nationals, and I got 4th place, I think, because I forgot to put a title block on a drawing, which is about the dumbest thing you could possibly do, but that's what I did. But that's kind of where I learned a lot of the drafting skills. And then the other part of the question is, what do I use to design? I do a lot of design on the iPad. So you may have seen in some of my videos, I draw in an app called Concepts. It's a really excellent technical drawing app. It's on the iPad, Android, and Windows 10, I think. But I do a lot of brainstorming on there. I usually have a pretty good idea of what I want to make before I do any CAD design. And then for the CAD, I almost always use Autodesk Inventor. Sometimes I'll use Fusion 360, but typically not. It's, in my opinion, having worked on Inventor for so long, Fusion 360 is kind of like a watered down version with terrible hotkeys and terrible menus. Another question: any large format SLA machines in front of us in your future? We have actually announced one that we are making very good progress on, called the Form 3L. So it's actually it's the same exact technology inside the Form 3. This is one of the really cool things about developing this product, is that it's very modular. So let me see if I think I have one. So inside of the Form 3, there's this thing called an LPU. And this is basically a one-axis laser scanning system. So it can scan the laser very quickly on one axis. And the neat thing about this is that it's a module that we make independently of the machine. And so it allows it to be replaceable. The optical system of a 3D printer, at least the SLA ones, is the most failing thing typically, because it's the most complicated and the most precise. But the cool thing is we can take multiples of these and put them inside another machine and make a bigger printer. And so that's actually how the Form 3L works, is there's 2 of these in it, and they're staggered, which lets it print bigger things. And then it's using a lot of the same software and process design and stuff. So it lets us have a big machine that's quite reliable and really good on day one, because it's built on top of all the stuff that we did before, which is neat, which is what I try to do with a lot of my projects. You might notice I use a lot of the same motor drivers and other stuff, because I spent a lot of time already developing motor control and other stuff. And if I can just jam the stuff I've worked on before, I can focus on solving new problems rather than the same problems over and over again. I've made many big projects over the last few months. Do I have time efficiency tips, or is that purely accumulated skill? So I work with a lot of engineers, and different people work in different ways. And the way that I work, especially on projects like this, is I try to only put time into things that I have to and that are going to advance me towards my goal. So it's very easy when you're working on something like this to go spend 2 days reading about something that's tangentially interesting, but it's not going to advance the project. And so I'm always asking myself, do I need to do this? Can I buy a part that will allow me to just avoid this problem altogether? Can I do it in a different way that's easier? And then the other thing that's a huge element for all my stuff is I try to spend as much time or as little time as possible fabricating things. I enjoy the fabrication. I think it's a lot of fun, but it takes forever. And that's what so much of my setup is designed to do, is to make it very easy to fabricate. So the reason I built the plasma cutter is that it's just so fast and so easy. I can make almost any structure that I want, plasma cut it out, bend it, spot weld it. You can have something in like an hour. The articulating backboard that sinks the shot, that whole structure for that thing took me like an hour to make with the plasma cutter. And then same thing with 3D printing. If I can 3D print it, I can. That way I don't have to spend my time doing it. And I will sometimes do things in less elegant ways because they're easier. So it's really easy to waste a lot of time making nice enclosures and stuff like that, but it can take forever. So, but the mindset of what is the absolute shortest path from where I am to where I want to be, and am I following that? That's basically how I'm thinking all the time. And after a project, I'll usually think, did I waste time? Could I have done it faster? Where did I go wrong? And in many cases, I knew I've wasted time on something, and I knew when I was doing that at the time, and I still did it for some reason. I can't avoid it at all times, but I try to. Vegetable-based resins, really less toxic. I don't know anything about vegetable-based resins, to be honest. And I don't think any of ours are vegetable-based, so I don't have anything smart to say about that. How often do I find myself stuck in a project and tap into others for help? Basically never. And that's not because I couldn't use help. That's actually probably one of the things that I do the worst, which is relying on other experts to help accelerate whatever I'm doing. At work, that I do this all the time. Very rarely is anything done independently. But I think part of the reason I like doing the side projects is that I have to figure it out. It's like being dropped into the woods somewhere and you have to figure out how to survive and get out. And that's kind of how I approach it, is just, all right, let's figure this out and get it done. It's all on me. I will succeed or I will fail. And I probably should ask experts for help more often. Like the USB thing that I was talking about earlier, writing the USB driver for the golf club. There's multiple people I work with that are USB experts that probably could have cut that time in half or more if I just asked them a few questions, but I avoided doing it because I just wanted to figure it out. How much do all the tools in my shop cost? It's actually probably less than you would think. The plasma cutter I built myself for maybe $1,500 plus the Hypertherm. It's a Hypertherm plasma power supply, but the gantry was probably $1,500 to $2,000. The first CNC was maybe $2,000. The Tormach, I actually got COVID pricing on it. that was part of the reason that I got it, was that I called them up and was able to work a deal because everyone was freaking out about COVID. That was in the like 20,000 range. And then my other mill was like 6,000. Those are all my big expensive tools. Almost everything else that I have is Harbor Freight. I don't have too many very expensive hand tools or anything like that. And so it's probably on the order of $50,000 or less. Did I make a lot of projects to seduce my loved one? I did. I definitely made her stuff. It's a thing that I value. So when there's someone I want to express value to, I make things. That's kind of how I do it. I actually made her engagement ring. I carved it out of wax. It would have been really handy if I had had a Form 3, because this prints in wax for jewelry. It would have taken like 10 minutes to print her ring. I spent probably 40 hours because I had to carve several. They kept breaking. It was very, very time consuming. But so I guess the answer is yes. What's my mechanical design process? Sometimes I'll have an idea and then 2 minutes later I've got something, but the steps in between are not as clear. So it's hard to say the mechanical design process. For a lot of stuff, the way I've described it in the past, which is not helpful at all, is I just know. Like, you state a problem, I'll know 5 different ways I could do it. That doesn't actually help anyone understand how I design things. So, and I've thought about what is the thought process that I actually do. So I visualize a lot in my mind. And usually what I'm thinking about is fundamentally, what is the problem here? So as an example, on the haircutting robot, I basically decided that I needed a way to grab my hair, and spending a lot of time playing with my hair, it seemed like the best way to do this would be to have 2 finger things that can slide in and then grab and then pull. And so if you think about it, there's a bunch of ways that you could do that. And I can put them on a rail. I can have them ride on like bushings or pins or something like that. I can put them on a pivot. And so I'm thinking about what are all the ways I can achieve the different elements of this. And then I'm thinking about, well, how hard would that be to make? How likely is that to work reliably? And how much complexity is there? So the reason I went this way is in thinking through all the different ways that I could do it, a pivot is the best. A pivot is so much easier than any kind of linear rail. So this has a linear rail for the scissors, and it was a pain to get working. A pivot is just a screw, so it's really reliable and easy to get working. That's why I did it that way. So the fingers ride on a little thing that pivots here. And then for making the fingers close, I could add a whole other servo that closes them or some motor or something, but that's another thing that I have to control, more wiring, and I also have to fit it in there. So I was realizing that I just need them to close as they go in. And what are the ways I could do that? I could do cams. I could do some kind of linkage or bars or something like that. I could imagine doing something with a gear or a push rod. And so just think through all the different ways I can do it and then combine them. And I'm looking for the best overall combination, and the things interact, how I can fit them and how they'll be controlled. If I'm going to do servos, it's convenient if everything's a servo. That way I just have the same kind of electronics. And that's generally what I'm thinking about. It's typically, I'm thinking about it in my head. I'll draw it if it's more complicated. And then I don't CAD anything typically until I have a nearly complete concept of how it's going to work, because the CAD is the slowest thing. And if you put a bunch of time into modeling a thing, that's the slowest way to figure out if an idea works or not. Do I have a vision of where I want to be in 5-10 years from now? I don't have a good answer to that question. The general answer, the general guiding principle for most of my decisions has been, how can I have as big of an impact as possible? And one of the reasons why I've been working on these 3D printers for so long is that I've been working on them for like 8 years now, is that they are extremely useful. They are used by millions of people to print tens of millions, hundreds of millions of things, which then make tons of new products and improve the world in a lot of good ways. And so I've always viewed the work I do here both as technically interesting and also impactful and rewarding. So that's what's really kept me working on this, and I still like doing it, and it's very enjoyable. The YouTube thing has been a hobby. It's a whole other thing. It's gone a lot faster than I possibly expected that it would. My goal going in, I was like, all right, if this is really successful, maybe I'll have 100,000 subscribers in a year, and we'll see how that goes, and that'll be interesting. And I'm reaching a lot more people than I expected I would. I think I'm having some kind of impact, but I don't know. It's hard to quantify. So I enjoy it a lot, but I don't have like a 5-year plan or anything. I'm just continuing to make my stuff and have fun doing it and hopefully entertaining people. Use a Flowbee to cut your hair. I was looking at using a Flowbee for this project, but it just seemed too easy. And this was a case where there was an easier way. And I talked about the shortest path from A to B, and a Flowbee on a stick would have been the shortest path from A to B. But I've heard so many people say hair cutting with scissors is like the hardest thing. And so I really wanted to see if I could. And so I set that as a requirement, like scissors and don't stab yourself. Like don't get hurt and use scissors. That was my 2 requirements going in. Can you get CAD files in the Patreon? Possibly. My CAD is a mess. So, I talked about the shortest path from A to B, right? Well, part of the shortest path from A to B is making terrible CAD, where you download files off GrabCAD and then like chop away half of it with a extrude cut and then add your stuff to it. I do a lot of CAD that way because it's so much faster. For most things, I'd be fine sharing step files. They're not going to be rigged well, and they're kind of crummy. So if people want that, I'm fine with sharing it, but it's not going to be great. Is there a particular mechanism that you're interested in? How old am I? I'm 32. According to the internet, that is impossible, but it's true. So, a few other questions that people asked in the Discord. Yeah, for the folks who aren't here who asked questions. So, what's the biggest contributor to the rapid growth my channel's seen? Was it a viral video or more calculated and planned? And the chatter. Sorry, I just saw the comment about the chatter on my age. I think it's hilarious. I like that people keep saying I look like random things. They're mostly not insulting, so even when they are, it's pretty funny. So I think it's good. I like comedy. So back to the question, the biggest contributor to the growth of my channel. So my approach going into all of this is I wanted to make videos that I would like to see. And what I would like to see is information dense, like tightly edited things that take me through a project from start to finish. There's a lot of people making videos. Is my audio still bad? Let me know if it gets worse. I can switch mics. But yeah, my goal was to make videos that I would want to see, and I did think about what is the most effective videos I could make I'm not going to have any impact if no one sees the videos. So that's an important thing. My goal is not to be famous. All my early videos, I didn't even show my face, but it turns out showing your face matters, I guess. And so I started doing that. And so I was thinking about what's the best way to have impact and grow and get viewers and things like that. And so I was focusing on videos that I would want to see with the best quality that I could do. This is another thing that I didn't have any idea what I was doing. So I just jumped into it and read some stuff and tried to figure out which way it was up. But I think that probably the biggest contributors to the growth is just that it is content that people enjoy, and I guess you'd call it quality. And I've focused on that rather than quantity. So when people see the things I'm doing, they say, oh, that's cool. Oh, he's doing other cool things. I like this. I'll follow the guy. And I think that's been helpful, which is totally against all the advice that you see when you search this kind of stuff online. People are like, make a video every 2 days if you can, and quantity is what matters. And that's just not what I'm doing. What discipline of engineering is my favorite? I love they're like my children. I love all of them. And I can't possibly pick a favorite, but if you really, if a parent had to choose a favorite, that they could, I think. And so if I had to choose, it would probably be software engineering. And the rationale for that is it's the field where you can make the most progress without the most resources. You can move mountains with software without tons of equipment or anything. And you can make amazingly complex stuff that's really interesting. And so if I got to only have one major, it would actually be computer science. Although mechanical engineering is my first love, and I hope I get to continue doing that. My project pipeline after the bat. I've got there's so many things that I want to do. Let me pull up my list. I haven't really decided. So I've had this violin project that I've been stewing on for quite a while. I've done a little bit of design, and basically what I want to do is there's like three different flavors. There's making a violin that plays itself. And the reason that's interesting to me is I think that I could make it play things that a human can't play. In particular, I'm interested in the idea of taking like a random MP3 file and then making the violin as closely approximate that MP3 as it can. That's a pretty cool software problem, I think, but also hard to engineer. So making the violin play really fast and being able to play notes that a human can't do. And then there's automating playing the notes while I play with the bow. That's another flavor, which is potentially compatible with the first one. And then the third one is I just kind of am playing, but it's correcting for me as I go. And I'm not sure exactly which direction I want to go. So that's one of the complicated projects. So I've talked on the channel about guided missiles a few times and how interesting they are. So where this all came from is I had two different projects, two different things I would love to see. One is I was really interested in the idea of, I was actually looking at one of these printers and I was thinking, so they have these cartridges that go into the top of them, they slide in. And I was thinking, if I lined it up perfectly, could I drop a cartridge from like 10,000 feet above the machine and it would go straight into the hull? And how cool would that be if I did that? And then I was thinking through like, well, what would it take in terms of guidance? Because air and stuff, you'd have to have some kind of correction. I was like, well, that's like a guided missile. That sounds kind of cool. But then I was thinking, why it needs to be something that's interesting. Like that's just a dumb problem. And then I was thinking about plugging in your phone from across the room. If I had a thing that could shoot the plug directly in the phone, that would be cool. And then that turned into, maybe an even more interesting application is watching Iron Man 3, I think, and he has the armor that like flies to him. And that seems like a really cool application of guided missiles that is also sort of constructive. It's at least not actively destructive. And so I really want to do that. I've been thinking about some different ways that I can do that. Certainly a general purpose thing that can fly through doors, that's not going to happen. But I do think that there's a way to make essentially a launcher that launches a single like gauntlet with a small amount of attitude correction such that it goes onto my hand. I think that's possible. So that's in my list. I would really like to do another iteration on the basketball hoop. I have some really big servo motors, not hobby servos, but BLDC, like brushless DC servo motors. I would like to make one that's full size and also moves laterally. So even the thing everyone says is, oh, haha, what if I just missed the basketball hoop entirely? Which, of course I didn't think of that, but I would like it to be able to move, catch the ball and direct it in. And it's kind of just taking it to the next level. I really like that project because you can just keep taking it to the next level until you get to the point where you just put a blindfold on someone and they can throw a ball in any direction and it'll go in the hoop. That's where I would like to get. But I think lateral movement is the next step. What do I use for editing my videos? I use Adobe Premiere Pro and then After Effects. And I like it a lot. I actually have a device I use with it. I always like tools that help me go faster. And it's called a Loupedeck. And it has basically all the controls for Premiere on a little touchscreen and a knob and some other buttons that are dedicated. And it just makes editing and doing color grading and volume and all that really fast. So it's great. What are the people I learned the most from on the internet? I honestly don't learn that much from people on the internet. At least not like from YouTube videos. A lot of people like watching YouTube videos to learn how to do things. I don't really. I would much prefer to read a textbook when I'm really trying to learn something, just because there's more detail in it and references that I can look at. But of the people on like YouTube that I've learned the most from, it would probably be Dan Gilbert. If you don't know him, he's a self-made billionaire, as far as I can tell, who started a company years ago making some kind of lithography machines that he sold to Kodak, I think. Don't quote me on all this, for like $1 billion. And he has a series of videos on rapid prototyping, and it's like 18 or 20 videos that go through sheet metal and press work and spot welding and lots of other stuff, lathe work, milling. That's probably the thing I've learned the most from. I've learned tidbits from channels like Tech Ingredients or Applied Science, but really I'm going to those to be entertained more than I am to be educated. How do I transform something that can be interpreted by the mill? It's using software called CAM. CAM stands for Computer Aided Manufacturing or Computer Aided Machining. I don't remember which. And it's software that is designed to take geometry and then generate a series of moves that a machine will do to realize different features in that geometry. I use HSMWorks specifically for most stuff. Sometimes I'll use Fusion. And then I also have Aspire. I recently got this CNC router, and I haven't really used Aspire, but I have that as well. But it basically, you will say, I want to make this contoured surface, or I want to make this hole here. I want to use this tool. And then you program it, is what they call it. And then it outputs typically G code, which is just a series of instructions that the machine follows. It's a pain. That's one of the reasons I try to avoid CNC machining. It's a lot easier with the Tormach because I have a tool changer and I don't have to stand there the whole time and change tools and stuff. But it still just takes a lot of time to set these things up, because every single thing that it does, you have to specify. My last name is Wighton, Wighton, if you want to stalk me on LinkedIn. I got a few more questions from folks that asked on Discord. How has life changed now that I'm YouTube famous? What's something I've disliked about rapid growth? So I don't really know if you call me famous, maybe YouTube known. Basically nothing has changed. I get made fun of at work for making YouTube videos. That's like the one thing that's changed. It's like I talk about something that's, oh, is that for a YouTube video? Or like, oh, you should make a YouTube video about that, all the time. That's like the only thing probably that's changed. How does wife made here really feel about my projects? She likes them. She's very supportive of them. That's why she's always willing to try them. She plays the in the videos. She is often being exasperated by me, but in real life, she's extremely patient and accommodating and encouraging. So she likes them. Last question that was in the Discord is, how has this impacted my full-time job? Have they tried to weasel some free advertising? Not really. I mean, they asked me if I wanted to do a webinar about sheet metal forming because I was using these machines to form sheet metal, which is something that people are interested in. And so I did that. That was fun. But I mean, they're pretty separate things. Like I go to work and I work and I do this stuff on my free time, and people are more aware of my personal projects because they're out there, but that's really the only difference. Oh, who's the guy I referenced? Yeah, Gelbart. That's how they put it in here. Gelbart. I think it's called, I don't remember. I couldn't. If you search that on YouTube, that's the name of the channel. But he has a series. I think it's like Rapid Prototyping Essentials or something like that. You should check it out. It's fantastic. In fact, Dan is why I made the plasma cutter, because I saw all this awesome bending stuff that he was doing. It's like, I need that, but I can't afford a water jet. So I'm going to make a plasma cutter, which is sort of like the poor man's equivalent of a water jet. Everyone already knew my name. It's all the articles that they post, they somehow have my name and post it. So it's already out there. What do I do for a living? I'm an R&D engineer. I run an R&D office for a company, Formlabs, where we design 3D printers like this, the Form 3. And almost all my work at this point is technical management. And I've got like 25 people that I manage right now. In the past, I was up in Boston and I was running the SLA stuff. So I was responsible for making Form 3, Form 3L, Form 2, stuff like that. So it's been going for an hour 12. I went through all the questions in Discord. Anything else, or should we end it? Hopefully this was interesting. I really appreciate everyone tuning in. If you have feedback on how this could be better or anything, I would love to hear it either now or in the channel or anything like that. I'd actually tried to write down some questions that I had just to think about. You don't have to answer them now. But basically, what can I do to improve? I'm always interested in that, whether it's the videos or the projects or whatever. We're interested in that. If you think there's a project I should do, always interested in hearing that. I love good ideas. And then there's been a lot of requests for additional content, which I'm actually pretty interested in doing because these projects take forever. And I put there's so much neat things that go into them. And then I go to make these videos and I have to edit them down to be something that you can put on YouTube reasonably. And so many details are left on the cutting room floor. And I've been trying to find a way to share more of those details, which I know a lot of folks are interested in as well. And so I've been thinking about maybe a podcast, the rationale being that those are a bit easier. Like I'm not going to just put it off because all I have to do is just record it. I don't have to make a bunch of video and stuff like that. But the question I have for people is, would that be interesting at all? Is it video? Like, what is it? What information would you be interested in beyond what I show in the videos about my projects? And then if it's describing the problems, how and about them, then a podcast could be interesting. But if it's showing how I CAD, then it's pretty hard to do that in a podcast. So I'll probably dump these questions into the Discord channel just to pick everyone's brains. But something to think about, something I would love to get more insight into, and something I'm thinking about doing. And then, looks like there's a couple more. So if you want to make a plasma cutter, where do you begin? Where I began, is I looked at pictures of everyone who had made plasma cutters to just try to get an idea of the different ways of doing it. There are a lot of designs out there, and in my opinion, they are mostly not very good. And so, and for various reasons, some of them are they can't achieve high top speeds, which are very important. Others are extremely overbuilt for what you're doing with plasma cutting, so it's just a bunch of wasted material. And I would start by looking at things that you can buy first. So there's actually a couple good options now that weren't available when I built mine. There's a company called Langmuir Systems. I think that's how you pronounce it. They make a machine called the Crossfire and the Crossfire Pro. These are like $1,500 or $2,000 plasma tables, and they come ready to, like, you assemble them, but they have everything you need except for the plasma cutter power supply. And they make they're 2x2 and 2x4, I think, feet. So if I were going into it now, I would probably buy one of those over building. It was a fun project, but it's also, it's a big project. But it's, yeah, I don't know. It's a tough one, but I would look at what other people do. I would learn a lot about the electronics and the controls and everything that you need software wise. Learn about torch height control. If you are going to build one, you definitely want to be able to achieve at least 300 inch per minute speeds. You want to have really high accelerations, because if you don't have high acceleration, your corners will not be cut well. They'll typically be eroded and terrible. And then you need Z height control, torch height control. It is like just a requirement. If your material is warped at all, you just have such a terrible time. And torch height control is looking at the voltage of basically the cut head to the work. And it turns out that is basically proportional to the distance that the cutter head is from the metal that you're cutting. And then it'll use that to adjust the Z axis so that it stays the same height above the material. You want that. So there's a bunch of websites, a bunch of forums. If you have specific questions, you can ask me in the Discord. Like if you get into it and you want to know about it, there's things I would do differently for sure, having built one now. And I'm happy to share my learnings so that you don't have to learn them the hard way like I did. And I would recommend it. They're great. If you have the means and the space and you make stuff out of sheet metal, or you want to make stuff out of sheet metal, it's so much easier. The CNC mill, I did all that sheet metal without one, and that it was so terrible. That's why I built it. It's just so much easier. All right. Well, I think we're getting close to a good end point here. So yeah, again, if you have feedback, let me know. I really appreciate all the support. For people who aren't here in the beginning, I'm putting 100% of it back into projects and improving my production quality. And I really appreciate it. And it is enabling me to do a few more things, like get a better camera. So I really appreciate it. And I really enjoy the Discord. So, don't be afraid to ask questions or talk. I think it's a fantastic place. I'm not doing it because I have to. I'm actually really enjoying it. So, don't be shy. And I'm far from the only interesting person in there. You see the things people are saying, there's like almost every person is super awesome. So it's great. I love it. So yeah, have a good, whatever time zone you are, morning, evening, Australia people, sleep. And we'll do this again in a month. Goodbye.